In this video, we're going to look at finding a side given one angle and one side. And I underline side and angle. We're going to see in the future these called S and A. In this case, we have SAS, we have side, angle, side. So let's have a look here at a question. If we want to estimate, and this could be the height of a building, you could be walking this direction along the ground and then measuring the angle up to the top of the building and count your steps. You've gone 50 steps, you've got massive steps, they're all 1 meter, and you measure the angle here, and the angle, if you have a clinometer or a protractor, let's say, and the angle here is 40 degrees, you will be able to measure the height of the building, which we're going to call X. You can see here we have one angle to 40 and we have one side 50. Now we do it the same way. You've mastered in the first section of trig finding an angle given two sides and Pythagoras, so this is a combination of the two. So let's label this triangle the way we would have done before. H and A touching off the angle, H opposite the right angle, which I should have put in, A touch off the angle, and X is over here, and that's it's opposite to the angle. So in this case, we're going to start off by saying, well, what do we have here? Let's look at this triangle. What have we got? We have A. We need, or we want, O, that X there. So we're labeled them O and A. What are we labeled? This is SOHCAHTOA, as you have written down so many times at this point. You should know it off by heart. Sine, opposite hypotenuse, cos, adjacent hypotenuse, and tan, two straight sides, opposite and adjacent. So we have A and we need O, and you can see here tan is the only one that has O and A in it. So we can say that the tan of the angle in the triangle that we've labeled it from, which is 40 degrees, is equal to O over A. The relationships between the sides here is X for O, and for A we have 50. You can see if I just write beside that, that's O over A. You don't have to write this in a question in an exam, but if you do, you won't be deducted marks, and you're just kind of showing a little bit of extra work for yourself. Slow yourself down and show that you're right. So if we multiply both sides by 50, we get 50 tan 40 is equal to, well, technically it would be X over 50 times 50, so the 50s cancel, so it just leaves X there, which is the height of the building. And if you type into your calculator 50 tan 40, you've done your first experiment in trig by taking these joint leaps and measuring the height of a building to be this 40 degrees. And X in this case, if you type 50 tan 40 into your calculator, it will give 41.9548 and so on. So we'll just take two decimals here, 41.95 meters. Now, let's continue with this same triangle to find a conclusion that we can make. What happens if we increase the angle that's 40 or decrease the angle that's 40? What if you were asked, walk out the same distance as the height of the building? What would happen? So let's have a look at if we reduce the angle from 40. We walk out now and we're going to reduce the angle to 30. So now if we look at our triangle, we have 30. We don't know, we forgot to count our steps. So we're going to see, well, how far have we walked? So we have X this time, as we'll round X off to 42 meters here. It's very close, 42 meters for the height of the building. So now if I label my triangle, H and A touch off the angle. So my hypotenuse, which is opposite the right angle, and A touch off the angle. And O is the side opposite. So now what we have O, and we want, or we need, A. How many steps have we taken? So what we say is we use tan, so the tan of the angle, the tan of 30, is equal to O over A. I'll write it off to the side here, O over A, which is 42 over the adjacent side, which we just called A, so we leave it as A. So if we multiply, so if we know our algebra, we know that the tan 30 and A swap places, but we'd have to multiply both sides by A tan 30 would be equal to 42 over A times A. If you want to multiply both sides by A, these end up cancelling. we get A tan 30. Now I'd advise you to just do this the quick way, but if you haven't seen this before, A tan 30 is 42. So A is equal to 42 divided by the tan of 30. So have we walked out further or have we walked closer to the building? Now A in this case is going to give an answer of 72, and if we round to 2 decimals it'd be 75, so we'll round it off to 73. So A is 73 meters, so we've walked further. And of course that makes sense. If we're here and we're walking this way, the further we get out along this line, you can see the narrower the angle is going to be. If I try to connect up this triangle, this angle is getting smaller and smaller as you get bigger or further and further away from the point. So let's look at a couple of more of these triangles, just really simple questions. Those first examples, you won't start with them, you just be given a triangle with a right angle inside it. You'll be given an angle and you'll be given one of the sides. It doesn't really matter which side. We'll start with the 2 straight sides and we'll do a tan question. So if I say this is 5 and I want the bottom, we can see the 2 straight sides is going to be tan. So I'll just set up 3 questions first. We can see how do we set up a cos question. So I'll just use the same triangle 3 times to start. So if this angle is 20, cos is A and H. So let's say I want H, we'll call that one X, and A is the one down beside it. H and A touch off the angle, we'll call that 10. And that's a cos question because we're dealing with A and H. And to set up a sine question, it's O and H, the 2 sides that we're dealing with. These are just right angle triangles for now, but you saw already they could be buildings, they could be anything. So sine is O and H. Now I'll put the angle up here just to mix it around, and I'll call it 45. For a reason, let's have a look here then. Well, we want O and H for sine. I'll just write SOHCAHTOA off to the side here. SOHCAHTOA. You guys, do you know it off by heart yet? If you don't, keep writing it. So sine, we're dealing with O and H. So let's say we have H this time is 25 and we want O, and we'll call it X. So take your time, pause the video when you're looking at these for the first time, and now maybe practice them if you're confident. If you're not confident, just look at it being done.
Sure.
You can see in this first question here, we have O. Now we know we're dealing with tan, but let's just set up the line. We have O and we need or we want, we have a leveler triangle, H and A touch off the angle. You don't have to keep doing this if you get really confident, but do it until you get confident. So if H and A touch off the angle, if we have O, we need A. So we're going to use tan. The tan of the angle that we've labeled the triangle from, the tan of 30, is equal to O over A, SOHCAHTOA, and O over A in this case is 5 over X. And we saw from the algebra previously that when we have a situation like this, the unknown and the left hand side just change places. So X is equal to 5 over tan 30. There's only 2 things that can happen at this point here, so just be really aware of what they are and learn them off quickly. And if you type into your calculator 5 divided by tan 30 will give 8.66, and we don't have any measurements here, so we'll just call them units if we get to the end of the question and there was none given. Okay, let's label our triangle. H and A touch off the triangle. O is not required here. We have, what do we have? We have A and we need H. So A and H is cos. So we say the cos of the angle inside the triangle, 20, is equal to A over H, which is 10 over, we've called HX, and the same algebra as here. They just swap places. So X is equal to 10 divided by cos 20. And if you divide 10 by cos 20, you're going to get 10.64. And again, I'm going to write units. I'm going to call this meters, so I don't have to write units in the next one. Okay, so you can see X is slightly longer than the bottom. So the last triangle, if we label it, H and A touch off the angle, so we have to have H here and A here, which leaves O down the bottom. So we have H and we need O. You guys are identifying now O and H, and you're just looking at SOHCAHTOA, and you don't need this bit if you get good at them. But until you get good, please slow yourselves down. where you're doing the same thing repetitively, so that repetitive motion becomes knowledge rather than something that you're just doing. So we're going to use sine here, or sin. So the sine of 45 is equal to O over H, which in this case is X over 25, and slightly different algebra than the first two at this point. We cross multiply by 25 here, and X will be on its own. So 25 sine 45 is equal to X. And if we type 25 sine 45 into our calculators, we're going to get 17.677, which will be 17.68 or 17.7 or 18, depending on what we were asked to round off to. Just an example of rounding here in the last part of this video. So go back, rewind a little bit, try these questions again. You see the answers here. And go on to the next one of these videos and practice again. Because practice makes